Hello everyone, welcome to CR Maths class. Now I am going to discuss theory of equations concept. So previously I completed quadratic equations and level 1, level 2, level 3 problems. Now new chapter. See, quadratic means degree 2. Quadratic means we know that degree 2. If degree 3, we will say that what? Cubic. Degree 4, what we will say? Biquadratic. Degree 5, fifth degree. Degree 6, sixth degree, and so on. Degree n, this is nth degree polynomial. Then what is degree 1, students? Degree 1 means linear. Degree 1 means linear polynomial. Degree 0 means constant polynomial. This concept already we have discussed. Okay. Now, what is nth degree polynomial equation? An expression of the form f of x is equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus and so on an, where n belongs to natural numbers. A naught, A1, A2, A3, and so on. An are complex numbers where A naught is not equal to 0. Then f of x is called polynomial in x degree n. Polynomial in x degree n. Okay. Now f of x is equal to a naught. A naught means what? That is constant. Then what is the degree? 0. So f of x is a constant polynomial or 0 degree polynomial. The polynomials of degrees 1, 2, 3, 4, we can say degree 1 means linear, degree 2 means quadratic, degree 3 means cubic, degree 4 means biquadratic polynomials. Just now I discussed. Okay. Degree n means nth degree polynomial equation. Okay. Next. If nth degree polynomial equation has at most n roots, if quadratic equation has maximum 2 roots, at most 2 roots, remember it. What is the root or solution of the equation? In the given polynomial equation, in place of x, substitute alpha. F of alpha is equal to 0 means then alpha is root or solution of the polynomial equation. F of x is equal to 0. Understood? This thing already you know very well. Okay. Next, fundamental theorem of algebra. Every polynomial equation of degree n greater than or equal to 1 has at least one root. The degree is 1, linear, quadratic, cubic, biquadratic, like that. So each and every equation, observe that at least one root is there. Okay. If constant polynomial, there is no roots. Right. Every polynomial equation of degree n has only n roots, no more. That means maximum n roots only. So in that roots, how to identify that? Imaginary roots, conjugate roots, real roots, those are equal roots, like that. In an equation with real coefficients, imaginary roots occurs conjugate pairs. Yes, we know that. What is imaginary root? Take one example. Alpha plus I beta. This is one complex number. Alpha is the real part, beta is the imaginary part. Alpha plus I beta is imaginary root. What is conjugate of alpha plus I beta? Alpha minus I beta. That means one of the root is complex, means compulsory conjugate roots is also complex only. Okay, alpha plus I beta is one root, then another root is alpha minus I. So one root is imaginary root, means it is occurring conjugate pairs in an equation with rational coefficients. Rational coefficients. Real coefficients means we get imaginary. Rational coefficients means we get irrational roots. In case irrational roots are there, those are conjugate pairs. Conjugate surds. Irrational root means in the form of like this, 5 plus root 2. What is conjugate? 5 minus root. This is imaginary root. This is irrational root. Either imaginary root or irrational root. Both are conjugate pairs. Exist for conjugate pairs. Remember it. Next, the function of the roots of an equation which remains unaltered in value when any two of the roots are interchanged is called symmetric function. Or suppose quadratic equation is said. Quadratic equation means you know that there are two roots. If you are interchange the roots, suppose alpha value is 3, beta value is 5. Or suppose you can interchange like alpha pi 5, beta 3. Okay, so there is no change in that polynomial equation. Okay, right. Next, problems on quotient and remainder division algorithm. What is division algorithm here? F of x comma g of x are two polynomials, and f of x by g of x. F of x is divided with g of x. So you know that long division. How to write this? This is g of x. This is f of x. Now this is remainder r of x. This is q of x, quotient. Q of x means quotient. R of x means remainder. G of x means divisor. F of x, dividend. Okay. So finally, observe here how to write division algorithm. F of x divided by g of x is equal to, first we can write q of x plus r of x by g of x. Understood, students? Right hand side, first we need to write q of x plus r of x divided by g of x. And left hand side, right hand side, take LCM. Left hand side denominator, right hand side denominator, both are going to cancel. Then we get f of x is equal to q of x into g of x plus r of x. This is called division algorithm. Okay, so this is already you know in 8th, 9th standard. And degree of r of x is less than degree of g of x. Q of x is called quotient, r of x is called remainder, and f of x, g of x you know very well. G of x is divisor, f of x is dividend. Students understood what is division algorithm? Remember it. Okay. Remainder theorem. What is remainder theorem? If a polynomial f of x is divided by x minus a, the polynomial equation f of x is divided by x minus a, then remainder is f of a. Okay, For suppose the polynomial equation f of x divide with x plus a, then what is the remainder, students? F of minus a. How we got? X plus a is equal to 0 means what is x minus a? This is substitute here. Then you'll get the remainder. Understood? Right. Next. For suppose roots given, then how to find a polynomial equation? Already we know that in previous class, previous chapter we discussed alpha, beta are the roots means how we are forming the quadratic equation. X minus alpha into x minus beta is equal to 0. After multiplication, you will get like this: x square minus sum of the roots into x plus product of the roots is equal to 0. If alpha, beta, gamma, delta are roots of the equation, how to form the polynomial? X minus alpha into x minus beta into x minus gamma into x minus delta is equal to 0. If in case here minus alpha is there, here will come plus. Understood? Now, for suppose n roots given, the equation having n roots, alpha 1, alpha 2, alpha 3, and so on, alpha n. How to form the polynomial equation? X minus alpha 1, x minus alpha 2 into, and so on, x minus alpha n is equal to 0. If you simplify that, you will get nth degree polynomial equation. Understood? 2 roots are there means we can write like this: 4 roots, 5 roots, 6 roots, whatever may be. After writing like that, then multiply, do some calculation, you will get polynomial equation. Okay, roots given means how to find the polynomial equation we learned. Now, what is the relation between roots and the coefficients? Alpha 1, alpha 2, alpha 3, and so on, alpha n are roots of the equation, polynomial equation. A naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus and so on, plus an is equal to 0. This is nth degree polynomial equation. There are n roots. In previous chapter, we know that alpha comma beta are the roots of the equation ax square plus bx plus c is equal to 0. Only 2 roots now. S1 sum of the roots, S2 product of the roots. Sum of the roots formula minus b by a, product of the roots c by a. See here, S1 means x minus of x coefficient by x square coefficient. S2 means constant by x square coefficient, like that. Same like that here, there are n roots. That means this is nth degree polynomial equations. Now the relation between roots and coefficients we get S1, S2, S3, and so on up to S1. What is the S1 means? Sum of the roots. Sigma alpha 1 S1. What is the formula? Minus A1 by A naught. Now S2. S2 means sum of product of the roots taken 2 at a time. That means sigma alpha 1 alpha 2 plus sigma alpha 2 alpha 3 plus sigma alpha 3 alpha 4, like that. So this is, we can write A2 divided by A naught. Next, S3. Sum of the product of the roots taken 3 at a time. That is sigma alpha 1, alpha 2, alpha 3. That is equal to S3 minus A3 by A naught. Here observe that clearly. What is the difference S1, S2, S3, S4. Up to I am writing S4. S1 means A1 by A0, but negative will come. S2 means A2 by A0. Here is positive. S3 means minus A3 by A0. S4 means A4 by A0. Here observe that clearly. If it is the suffix is even, we get positive. The suffix is odd, we get negative. And each and every term observe that the denominator is A0 only, highest degree coefficient. This is the technique to remember. Okay. Now tell me what is S100, or suppose S100, A100 divided by A0. So here either plus or minus. 100 is even number. Compulsory we get plus only. Okay. Then what is Sn? Sn. N is even or odd? We don't know. That's why we can write minus 1 whole power n into an by a0. Sn means product of the roots, because nth degree polynomial equation now, product of roots. It is denoted by Sn minus 1 whole power n into an by a0. These are the formulas of relation between the roots and coefficients. Okay. This is the first important point. In an equation, all the coefficients are positive. Then the equation has no positive root. All the coefficients are positive means the equation has no positive root. All are negative roots only. This is one sign. Remember it. In an equation, if all the coefficients of even powers, even power means x power 4 coefficient, x square coefficient, x power 6 coefficient, those are all the coefficients of the even powers of x of same sign, and the coefficients of odd powers of x are opposite. Or suppose I will write one example. See here, x power 6 minus 2x power 5 plus 3x power 4 minus 4x cubed plus 5x square minus 6x plus 7 is equal to 0. Yes, see that even powers coefficients all positive, odd powers coefficient all negative. In this case, we can say the equation has no negative roots. No negative roots. Those are either positive or complex. Negative roots not possible. Understood? Or another method also is there to find how many real roots, how many positive real roots, how many negative real roots, how many imaginary roots. One more method is there. I will discuss. Don't worry. But remember it, these conditions. Third one, in an equation, the powers of x are odd and all the coefficients are same sign. Then equation has no real root except 0. All the powers of x are odd and all the coefficients are of the same sign. Then the equation has no real root except 0. 0 possible. Fourth point, all the powers of x are even and all the coefficients are of the same sign. Then equation has no real root. No real root. That means I will explain one example. X power 6 plus 3x power 4 plus 10x square is equal to plus 8. See here, all the powers are even and their coefficients also positive. In this case, overall, this is 6th degree polynomial equation. There are 6 roots. Out of 6 roots, there is no real root. There is no real root. That is the meaning of that. Okay. Next, this is a shortcut method, very, very important. Product of 2 roots equal to 1. This is 4th degree polynomial equation. There are 4 roots. Product of any 2 roots is equal to 1. Sorry, is equal to the product of other roots, other 2 roots. For suppose 4th degree means we can expect 4 roots now. Alpha, beta, gamma, delta. For suppose alpha, beta is equal to gamma, delta. Product of 2 roots is equal to product of remaining 2 roots. These 2 conditions equal means now the condition is p square s is equal to r square. But see the polynomial equation. Highest degree coefficient is 1. X coefficient is p. X square coefficient is q. X coefficient is r. Constant is s. In this case, we can apply the form. Okay. Next, the condition that one root may be the sum of the other 2 roots. This is 3rd degree polynomial equation. For suppose those roots are alpha, beta, gamma. One root is equal to sum of remaining 2 roots. This is the condition. Alpha is equal to beta plus gamma. In this case, this is the shortcut method. 8a square d plus b cube is equal to 4abc. Okay, remember it, shortcut method. Next, the product of 2 of the roots may be -1. Then this is the condition. A into a plus c plus d into b plus d is equal to 0. 3rd degree polynomial equation. Product of 2 roots is equal to -1. In this case, we can use the shortcut formula. A into a plus c plus d into b plus d is equal to 0. Okay, students, these are the shortcut methods. Please remember it. I discussed only 3 shortcut methods here. Okay, so remaining I will discuss next class.